Welcome to the video on orbital diagrams, drawing orbital diagrams. In class, you learned how to draw the pictures for your project, for example, for the S and the P and put the electrons in their S and P, and on the test, you need to be able to do this. You need to be able to draw all the way up to calcium and assign the electrons in the right places. Now this is great, but it's really difficult, especially if you're trying to draw anything in the D's. That would just be crazy. And even now, it's kind of tedious if you're trying to get all the way up to the calcium. And on the test, I'm not going to put more than one question on this because I don't want to look at all your drawings and try to parse through them and figure out where all your electrons are in your 1s, your 2s, and stuff like that. So let's talk about an easier way to represent the electrons and where the electrons are located. It's the exact same information as what you know here, but it's going to be a lot easier, a lot faster for us to draw it. It's called orbital diagrams. So here's the idea. We are going to use a representation of the subshells that are not actually those shapes. We're going to use boxes. So instead of drawing S as a circle, we're going to draw it as a box. And instead of drawing P as that sort of dumbbell shape, it's also going to be a box. So a box is going to represent an orbital. And because we have one, so we have S, we have one orbital. Actually, let me erase this. Make it better. So S, orbitals, it has one, so therefore we're going to draw one box. P has three orbitals, so we're going to draw three boxes, all connected to represent one P. And one P subshell, not one P, because there's no such thing as one P. Okay, D is five boxes, all connected. And F is 7 boxes. 1, 2, 3, 4, 5, 6, all connected. So now in our orbital diagrams, instead of drawing circles and propellers and dumbbells or whatever you want to call them, we're going to draw boxes. And our electrons, instead of being little dots on our circles and our dumbbells, they're going to be arrows in our boxes. And we talked about those arrows in class. We're going to have up arrows and down arrows. Now remember, we're going to follow Aufbau, Pauli, and Hund's rules, just like we did in filling our pictures. So according to Aufbau, we're going to start with 1s, and then 2s, and then 2p, and 3s, and 3p, and so forth. And we're going to draw these boxes when we get to that. So if we were to do 1s, we're going to draw one box. When we do 2s, we're going to draw another, one box. And then 2p, we're going to draw three boxes, and then 3s. As we go down and down and down on the periodic table. So that's Aufbau. Pauli says you can only put 2 electrons per orbital, which means you can only have 2 arrows per box. And those arrows have to spin in opposite directions. So you can have an up arrow and a down arrow. And then according to Hund, if you have a P, you're going to put 1 arrow in each box to represent 1 electron per orbital until they're filled up. So for example, let's try to do okay, starting over. Let's go ahead and do something like nitrogen. Okay, so if we're going to make the orbital diagram for nitrogen, it has 7 electrons. So just keep track of where we're going with this. We always start in the same place. We're going to start with 1s. And then we're going to put 2 electrons in the 1s. One up, one down. Then we're going to have 2s. So we're here. So we're going to put 2 electrons, 1 for lithium, 1 for beryllium. Then we're going to have 2p. 3 boxes. We have 3 electrons left. First of all, you can say, okay, we have already used 4 and I have a total of 7, so it's 3 electrons left. Or you can just use the periodic table, which I love. We're in 2p. Nitrogen is 1, 2, 3 elements into 2p. So we have 3 electrons to put in our 2p. And according to Hund, you have to put 1 in each box until each box has 1, and then we could go back and double up if we wanted to. So if this was nitrogen, we would stop here because it's got 3 electrons and it's 2p. If this was, for example, oxygen with 8 electrons, we'd have to put that 8 electron back again in the first box. Now people are like, okay, well, does it have to be in the first box? Not technically, no. Conventionally, we put up arrows in first, and then we go back to the first box and fill up the first box as we go through. That's just the way we do it. But technically, technically, you could put down arrows to start with, and you could put your fourth arrow in the last box, doesn't matter. But let's just keep with the convention of starting with the ups, starting with the box on the left, and then go back to the box on the left and fill in like that. So that is how you draw an orbital diagram.
Victoria and Olivia Delaney, can you please come to the main office? Victoria and Olivia Delaney, please come to the main office.
You can do orbital diagrams for any element. So I said for the pictures, you don't have to draw up until the d orbitals, but we could do a d orbital, a d element for an orbital diagram. So let's pick one. So let's do molybdenum. All right, I'm going to erase nitrogen and oxygen here. We're going to do molybdenum, MO. 42 electrons. Won't this be fun? Okay, we start in the same place we always start. 1s. 2 electrons. 2s. 2 electrons. 2p. 6 electrons from boron to neon. 1, 2, 3, 4, 5, 6. Now we're here. 3s. 2 electrons. 3p. 6 electrons. Now we finished argon. Now we're down to potassium. 4s. 2 electrons. Now we're into scandium. Okay, so we're farther along than whatever you had to do with the pictures. Scandium is in 3D. Remember, for the D's, you have to take your period number and subtract 1. So for period 4, we're going to do 3D. So after 4s comes 3D. We're going to have 5 boxes. We're going to have 10. 10 from scandium to zinc. Now you might have said, wait a minute, you told me I got to go one at a time until they're all filled in. I know that I'm going to fill in all of these because I know we're going all the way through to zinc. So I'm just going to fill them in as we go. And then after 3D, we have 4P. We're going to put 6 in there. That gets us up to krypton. We're almost there. 5s comes next. Like that. And now we are in 4D where molybdenum lives. We're going to draw all 5 boxes. But molybdenum is only 1, 2, 3, 4 elements into 4D. So we're going to put 4 electrons in our 4D. And we're going to go 1, 2, 3, 4, according to Hunt's rule. So you can do any element of any size with the orbital diagrams a heck of a lot easier than trying to draw a picture of them, especially once you get up to the D's. So that is orbital diagrams.